So I am recording, but feel free to stop me, right? If you have any questions, raise your hand. This is actually the second video I'm making on graphing parabolas on quizzes, specifically standard form quadratic functions. So standard form look like this: y equals ax squared plus bx plus c, right? Oh, I should do that in blue. And we've already talked about how the a value tells if it opens up or down. We've already told you how to find the vertex. You use the formula x equals negative b over 2a. We're going to use those skills to graph on quizzes. So obviously, even though we're doing it on quizzes, you got to do it on paper as well. Let's look at this first example. It says graph y equals negative x squared plus 9. And we always begin by finding that most important point, which is called the vertex. The vertex. And of course, the vertex is a coordinate. And of course, you find that coordinate using the formula x equals negative b over 2 times a. And when you use the formula, it's a great idea to replace b and a with parentheses. And then you go back to your original standard form quadratic equation, and you identify the a value, which in this case is the number in front of x squared, which is negative 1. So the a value is negative 1. The b value is the number in front of x, and notice that there is no x. And the c value is the number without an x at the very end, the constant, right? So again, it's ax squared plus bx plus c. A is a number in front of x squared, b is a number in front of x, and there is no number in front of x, which means that b equals 0. So there is no number in front of x, there is no x. So the b is 0, the a value is negative 1. So this is really simple because on top you have a negative 0, which is still 0, and on the bottom you have divided by negative 2. 0 divided by any number is 0. So x equals 0. That is the x value of your vertex. Now, whenever you have your x value and you want your y value, all you do is plug it in, right? Plug it in. So you're going to plug it into the original. The original equation is y equals negative x squared plus 9. And when you plug in 0 right there, it's really simple because 0 squared is 0. With the negative in the front, it's still 0. Plus 9, 0 plus 9 is 9. So y equals 9. So we just found the most important point, the vertex, 0, 9. That is a location on this graph, okay? So on quizzes, you're going to have this graph, and you're going to drag your mouse. And when you're dragging your mouse, that's going to be your first point. So you're going to have to go to the location 0 on the x and 9 on the y. And you leave your point right there, okay? And that's your vertex. Then you either make an input-output table to get more points, because like that's your most important point, but you need more points. So one option is to actually plug in numbers like 1, 2, and 3. Why would I not plug in 0? Because I already plugged in 0 for x and I got out a 9. So if I plugged in 0 again, I'd get out a 9 again. So you could plug in a 1. Now imagine that, 1 right here, you're going to do exponents first. 1 squared is 1. With the negative in the front, it's a negative 1. And negative 1 plus 9 is 8. So 1, 8 is a point, okay? And you could do that with as many points as you want, as many x values as you want. But anyways, let's go to the point 1, 8. So you would take your mouse and go to 1 on the x, 8 on the y, and you would be right there. Now, what I taught you before is what's really important is the a value. If the a value is positive 1 or negative 1, you know it's going to be exactly the same width as your original parent graph, which had the coordinates 1, 1, 2, 4, 3, 9. So once again, I want to repeat this, that it's kind of a waste of time. If your a value is positive 1 or negative 1, it's kind of a waste of time to go through and do all this math. It's a waste of time. Why? Because if the a value is 1 or negative 1, it's going to be the same exact width as the other parabola of the parent graph, which has a pattern 1, 1, 2, 4, 3, 9. We've talked about this pattern. When a equals 1, you're going to have the pattern 1, 1, 2, 4, 3, 9 from the vertex. Now, it is important to understand that it's negative, which means that's opening down. So from the vertex, 1, 1 is 1 over 1 down. And then you go back to the vertex, you go 2 over 4 down, and then 3 over 9 down. So that's what you're going to do. You don't have to do much math after finding the vertex. You're just going to get your next point, go 1 over, 1 down, put a dot there, go back to the vertex, 2 over 1, 2, 3, 4 down, put a dot right there, go back to the vertex 1, 2, 3 over 9 down, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there on the x-axis itself. And then you could use that same pattern in the other direction, 1 over 1 down, or you could have said, well, from here to here, it's 1 unit to the axis symmetry, 1 unit this way would be right there. Then you could map this point over 2 units to the axis symmetry, 2 units this way, you'd be right there. This last one, 3 units from the axis symmetry, 3 units this way, you'd be right there. And ladies and gentlemen, that is your parabola, okay? So again, I do not recommend doing an input-output table, an XY table, because it's a waste of time. It's a lot easier to just count with the pattern 1, 1, 2, 4, 3, 9. And the assignment for today has all of these parabolas with the A value of 1 or -1. So that means you're going to be able to use a pattern 1, 1, 2, 4, 3, 9 on all of them. Okay, let's do another. Check this out. Right here, it's a little bit more complicated. It's a quadratic trinomial. The A value is negative. You're going to start the way you always do by finding the vertex. How do you find the vertex? You're going to use a vertex formula, x equals -b over 2 times a. When you use the formula, use parentheses to replace the b and the a. Once you have it set up like that, go back and identify that the a value is -1, the b value is -8, and the c value you don't care about, it's not in the formula. Anyways, you're going to plug in the -8 as your b, the -1 as your a, and then you're going to do the math. Up on top, a -8 becomes a +8, and on the bottom, 2 times -1 is -2. So 8 divided by -2, that gives you a -4. That tells you that the x value of your vertex is -4. Now we still need the y value. Anytime you have the x and you want the y, plug it in. That's how you find the y. So we're going to rewrite the original equation. Y equals -x squared minus 8x plus a -17, minus 17. So now let's plug in the x value of -4 into those parentheses, and then we're going to do the math. You could type all of this in exactly the way it is, carefully on a calculator. It'll give you your final answer. Or you could do the math the way I'm about to, using PEMDAS. There's nothing to do in the parentheses, but you do exponents. And you're going to have to do this -4 in parentheses to the second power. That's a -4 times a -4. That's a +16. But don't forget about the negative sign that's in front. You're going to have to bring that down. So that's really a -16. Then you're going to go -8 times -4. That's a +32. Then you could bring down the -17. And from left to right, when you go -16 plus 32, that's +16. And +16 minus 17, that's a -1. And again, that is y equals -1. So now you have the y value of your vertex, -1. And once again, from here, you could graph this most important point. That would be -4 on the x and -1 on the y, and you'd put the dot right there. Now, you could use an XY table and plug in more points, or what I recommend is use the pattern when a equals 1 or -1, you could use the pattern 1, 1, 2, 4, 3, 9. Because a is negative, that means that it's going to be going down instead of up. It's going to be opening down instead of up. So from my vertex, I want to get another point, and I'm going to move it 1 over and 1 down because the a value is negative. Then you go back to your vertex, you go 2 over and 1, 2, 3, 4 down. Then back to the vertex, and you go 3 over, 1, 2, 3, and 9 down. That's going to be right there. And then, of course, you could use that same pattern, but in the other direction. So 1 over, 1 down, or you could simply map it over 1 unit, reflect it over 2 units, reflect it over 1, 2, 3, 1, 2, 3. That'd be the easiest thing to do, I would say. And there's your parabola. Now, of course, if you were doing this on paper, you would actually draw your parabola right through those points. But on quizzes, you're just plotting the 6 points, or 7 points in this case, of this parabola. Make sense? Okay. Might as well. Let's keep going here. Step 1, find the vertex, which is a nice coordinate. How do you find that coordinate? With the vertex formula, x equals -b over 2 times a. When you use it, replace the b and the a with parentheses. And then after you set it up like that, go back and identify that your b is -14 and your a value is -1. And when you do the math, a negative negative becomes a positive. So you really have a positive 14 up there. And on the bottom, 2 times negative 1 is negative 2. So our x value is really negative 7. That's our x value of our vertex. So I put the negative 7 right there. Now let's find the y value. How do I do that? Plug it in. All right, so let's rewrite the original equation. Y equals negative x squared, bless you, minus 14x minus 39. And we're plugging in the negative 7 into those parentheses. Negative 7, negative 7. Doing the math. By the way, if you're doing this math without the calculator, do not change the minus minus to plus plus. The minus minus changes to plus plus comes from the rule that a negative times a negative equals a positive. And according to PEMDAS, you do exponents before multiplying. So you have to do the exponent first. Exponent first. This does give us a positive 49, but the negative sign in front has to come down, and you're going to end up with a negative 49. And then you do negative 14 times negative 7. I'm just going to use a calculator, and that'll be a positive 98. Positive 98 plus 98. And then bring down the minus 39 at the end. And now you just add and subtract from left to right. When we say negative 49 plus 98, that's actually a positive 49. 10. And 49 minus 39 is 10, yes. So we found 10. What is that answer? That's the answer to y. Y is 10. So the vertex y value is 10. So let's go to the coordinate negative 7, 10. That's the most important point. So you're going to go negative 7 and 10. It's way up here. And you leave that vertex right there. Now, again, you could, if you wanted to, make a XY table and plug in some numbers that are on the same side of your x value. So maybe you could plug in a negative 6 and a negative 5 and a negative 4 to get some points on this side. But that's, like I said, it's a waste of time if your a value is 1 or negative 1, because if your a value is 1 or negative 1, you could use a pattern 1, 1, 2, 4, 3, 9. So that's super awesome when you have the a value of 1 or negative 1. So you could just take your next point and go 1 over, 1 down, and then take your next point and go 2 over, 1, 2, 3, 4 down. Take your next point, 3 over, 1, 2, 3, 9 down, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And then you could map the points to the other side of your axis of symmetry. Like on quizzes, of course, you can't draw this axis of symmetry the way we do on paper, but you could imagine that it's there and just reflect those points to the other side. So this point, 1 unit away, this next point is 2 units away, and this last point is 3 units away. And there's your parabola, right? Hit submit, that'll be full credit for this parabola. It's opening down, has a vertex negative 7, 10. Let's begin this one. Like always, find the most important point, the vertex, which is a coordinate. You find that coordinate using the formula. X equals negative b over 2a. When you use the formula, replace your b and your a with parentheses. Once you have it set up like that, go back and identify that your a is 1, your b is negative 12, and your c you don't really care about in the formula. It's not there. So let's plug in the b value of negative 12. Plug in the a value of 1. So you really have a positive 12 up on top because a negative negative changes to a positive, and 2 times 1 is 2. Therefore, our x value of our vertex is 6. And we now know the x value of the vertex. If you want the y value, all you have to do is plug it in, right? Plug it in. Plug it into where? To the original equation. The original equation reads y equals x squared minus 12x plus 34. And you could plug in that 6 right in there. And then you could do the math, either type it all in on a calculator or use PEMDAS. Start with exponents. 6 squared is 36. And then you can move on to multiplication. Negative 12 times 6 is negative 72. And then you could bring down that plus 34. Now from left to right,
34 or 39?
that is a 34. That's a C value, 34. And now from left to right, you just simply add and subtract. So if you go 36, that's negative 36. 36 take away 27 is negative 36, and negative 36 plus 34 is exactly right, negative 2. So you have the vertex of 6 comma negative 2. Again, the A value is positive, which is beautiful. Why? Because we could use a pattern 1, 1, 2, 4, 3, 9. Okay? So I'm just going to leave that pattern right here. And we're going to use that pattern 1 over, 1 down. Actually, 1 over, 1 up, 2 over, 4 up, and 3 over, 9 up. So here we go. Vertex, most important point is 6 over 6 and 2 down. So there's your vertex, most important point. It is opening up because the A value is positive. And again, it's positive 1, which means that you could use a pattern 1 over 1 up. If it would have been negative, you would have gone 1 over 1 down. Back to the vertex 2 over 4 up, 1, 2, 3, 4. Back to the vertex 3 over 9 up, 4, 5, 6, 7, 8, 9. Okay, I'm having some technical issues. I can't move these coordinates anymore, so I'm going to just graph the rest. I'm going to map it over to the other side. So just map it over right there, and right there. Again, how did I do that? I imagined my axis of symmetry, and then I went 1 unit, 1 unit. I reflected it. 2 units, reflected it 2 units. 3 units, reflected it 3 units. And there's my parabola. And of course, like always, if it were on paper, you would actually draw your parabola through those dots, put some arrows on it because it continues to the left and right forever and going up forever. Another one. Vertex. X equals negative B over 2 times A. Rewrite it negative parenthesis over 2 times parenthesis. Identify that your A value is negative 1, your B value is 12, and your C value is not in the formula. Doing the math, a negative 12 divided by, there's a negative 12. Whoops, let me change that color. Negative 12 divided by negative 2, that'll be X equals positive 6. Once you have the 6, plug it in. Okay, plug it into the original equation. Y equals negative X squared plus 12X minus 28. And we are plugging in that blue 6, the X value of 6. Doing the math, you start with exponents, but that's not a negative 6 squared, it's a positive 6 squared, and then you put the negative in front of your answer. So 6 times 6 is 36. Put that negative in front of the answer. You did exponents, move on to multiplication next. You have 12 times 6, that's 72. And then you have a minus 28 at the very end. From left to right, negative 36 plus 72 is a positive 36. And 36 take away 28. 36 take away 28 is, man, I can't think right now. I don't use a calculator. 8. Okay, so that is 8. And that means that Y equals 8. So we have our X value of our vertex being 6 and our Y value of our vertex being 8. And we do know that this parabola opens down because the A value is negative 1. And because it's negative 1, we are able to use the pattern 1, 1, 2, 4, 3, 9. Okay, so I'm just going to put this away because there's no space for it. But let's go to the first point, that vertex 6, 8, 6, 8. And then from that point, we know that it's opening down because A value is negative. So you're going to go the pattern 1 over, 1 down, back to the vertex. 2 over, 1, 2, 3, 4 down, back to the vertex. 3 over, 9 down, 4, 5, 6, 7, 8, 9. And of course, your next point, you're going to just map it over to the other side of the axis symmetry. That's 1 unit away from the axis symmetry. Go 1 unit this way. Next one, same deal, 2 units away, so go 2 units this way. And last one, it's 3 units away, so go 3 units this way. And voila, you are done. That's your parabola. Let's begin. Next question, finding the vertex. Vertex is a nice coordinate. The most important point, how do you find that coordinate? Using the vertex formula, X equals negative B over 2 times A. So that's a negative parenthesis over 2 times parenthesis. Make sure you identify your B value of 4, your A value of negative 1, and the C value is not in the formula. So you have a 4 right there and a negative 1 right there. So you really have a negative 4 over a negative 2. So your x value is actually a positive 2. That's the x value of the vertex. Once you have that x value of 2, I want you to plug it in. And when you plug it in, you simply rewrite the equation. Y equals negative x squared plus 4x minus 10. But instead of x's, we put parentheses. That way we could easily plug in that blue x value of 2. Doing the math, you do the exponent first. That's a 4. Bring down the negative that's in front. And then you could multiply next. 4 times 2 is 8, so plus 8. And then at the very end, you have a minus 10. From left to right, negative 4 plus 8, that's a positive 4. Take away 10. Your final answer is going to be a negative 6. That means that your y value is negative 6. So our y value of our vertex is negative 6. This is the most important point of the parabola. Let's plot one of these points. And that is a positive 2, negative 6. Positive 2, negative 6. Put the dot right there. Now, this a value is negative 1, which means that we are going to be able to use the pattern 1, 1, 2, 4, 3, 9, but it's going to be opening down instead of up. So we're going to take this next point and 1 over, 1 down, okay, because it's negative. Then you take the next point and you're going to go 2 over, 4 down, 1, 2, 3, 4 down. And if you take the next point and you go 3 over, 9 down, you're going to be off this graph. So that's why I'm only saying plot 5 points. So we have 3 so far. Just map them over to the other side. And you will now have a total of 5 points. So that's good enough. It's not 7 points, it's 5 points. We just graph 5 points. The parabola does go down forever, but the graph is only a 10 by 10 graph, so we're only able to plot 5 of those points. Now, technically, there's millions of points right here, but these are the nice points that have integer values. Like you could have the input 2.5, but then the output would be like negative 6.25 or something, right? So yeah, there's tons of points, but these are the nice points, and that's what I want you to plot on quizzes. And there's the last example that I'm doing on this video. Let's begin, like always, by finding the vertex. And you do that vertex using the formula x equals negative b over 2 times a. When you use the formula, replace b and a with parentheses. After you set it up like this, identify your a of 1, your b of negative 8, and your c you don't care about on this formula. So that's a negative 8 right there, a positive 1. So a negative and a negative change to a positive. What we really have here is 8 divided by 2. So your x value is 4. That is the x value of your vertex. The x value is 4. How do you find the y value? Simply plug it in. Plug it into the original equation. The original equation reads y equals x squared minus 8x plus 10. And you are plugging in that blue 4 that is the x value. When you do the math, you could either type it all in on a calculator or do it as I'm doing it right here. Exponents first. 4 squared 16. There's no negative in the front, so that's just a regular 16. Then you move on to multiplication. Negative 8 times 4 is negative 32. Then you could bring down the plus 10. At the very end, just go from left to right. 16 take away 32, that's negative 16. Negative 16 plus 10 is negative 6. So the y value of your vertex is negative 6. That is the most important point for negative 6. So let's take a point and go to 4 and negative 6 and put the dot right there. Now this parabola is opening up because the a value is positive. Not only that, it's the a value of 1, which implies that we could use the pattern 1, 1, 2, 4, 3, 9 from the vertex. So you're simply going to take the next point and go 1 over, 1 up, and then take the next point, go 2 over, 1, 2, 3, 4 up, and then take the next point and go 3 over and 9 up, 4, 5, 6, 7, 8, 9. And then all you got to do is map it over to the other side, 1 unit away from the axis symmetry, 2 units away from the axis symmetry, and 3 units away from the axis symmetry. And there's your parabola. I hope this video helps, and I hope you guys know how to graph parabolas that have the a value of 1 or negative 1.